holes are still somewhat of a mystery to us. However, that may not always be the case. What we do know is that they're pretty scary, and our galaxy alone is thought to contain at least 100 million of them. Yes, 100 million. Hello and welcome back to Life's Biggest Questions. I'm Rebecca Felgate, and today I'm asking what would happen if Earth fell into a black hole. Black holes are wandering around our cosmic hood. Their gravity is so dense that they're not stuck in orbit of other objects. They also don't emit any light or radiation, so you can't see them, making it hard to know exactly where they are. We can, however, see the hole's effect on nearby matter. Unless there is a lot of nearby matter, black holes can sneak around undetected. There are two types of black holes: supermassive black holes, which are at the heart of every galaxy, and stellar mass black holes, which are the ones that can really creep up on you. The nearest stellar mass black hole we know of is thought to be just under 3,000 light years away and is about 9 times the mass of our sun. So what is a black hole exactly, and why would it matter if we got too close to one? While there is no doubt that we have a lot left to learn about them, black holes are very, very dense. They're so heavy that they start to bend space and time inwards. Obviously, if they're able to bend space, black holes are denser than our sun, which means if one came close to the Earth, the gravitational pull of our solar system would shift. This would mean planets would be torn from orbit and likely smash into one another. If we were able to avoid any planet smashing, we would quickly discover that Earth has become a dartboard for asteroids. Asteroids orbit too. As much smaller rocks, they would be easily torn from their current paths and hurled towards Earth. This would not be ideal, as this could cause widespread death and destruction, and possibly a number of fires. If we, by some chance, managed to survive that, the next part would actually end humanity altogether. As we're drawn closer to the black hole, our atmosphere would be torn away and sucked in. Then, parts of the planet would break up itself. Also, the radiation created from all the other broken apart materials from other planets and cosmic junk would be very, very intense. We might be dead, but what happens then? What happens when we cross the event horizon and start traveling inside that hole? Well, honestly, we don't really know, but there are some key theories out there. The first is of spaghettification. Some scientists think that at the bottom of a black hole is one point of singularity. Our Earth would be broken apart, molecule by molecule, in a funnel effect, leading down to this very dense point of singularity. We would be stretched out like spaghetti, so thin that we would exist atom on top of atom. There are other theories that black holes aren't actually black holes, but doors to the other side of the universe. I don't want to mind boggle you, but as black holes already bend time and space, many think that they fold time and space, and that matter comes out the other end and expands outwards, like a big bang. We know that our universe is expanding. We can see it. We know that it started in a very hot, dense place and exploded outwards. Could we have come out of a black hole? Another theory is that if Earth fell into a black hole, we actually wouldn't even notice. Some scientists believe that instead of being destroyed, any material that touches a black hole turns into a near-perfect hologram. So far as we're aware and can hypothesize, the only way to escape being sucked in by a black hole is to travel faster than the speed of its gravitational pull. So, faster than the speed of light, which is something we're not even close to being able to do. Our solar system has been doing fine for 4.5 billion years, which suggests that we've never come into contact with a black hole yet, so we probably shouldn't even worry about it too much. That being said, there could be a risk of black hole danger on Earth itself. Scientists have created something called a Large Hadron Collider. This smashes particles together and is thought to be able to create a black hole. This collider costs billions of dollars and is designed to help us understand particle physics and the origins of the universe. But it could be powerful enough to generate a miniature black hole. On that note, we're gonna end this video here. What do you guys think would happen if Earth fell into a black hole? Have I accurately described it, or is there extra information? Do you believe in hologram theory? Are we living in two universes? Let me know your thoughts in the comments section down below. Also, please do hit that like button and share this video with your black hole loving friends.
Black holes are as mysterious as they are disastrous. They are a small region of space with a great amount of matter packed into a small area. They have a gravitational pull so intense that no matter or radiation can escape the event horizon. Thankfully, Thankfully, no black holes are near our solar system. But let's imagine, just for the next few minutes, what would happen if a black hole got close enough to our solar system that it began to devour our sun. Hello and welcome back to Life's Biggest Questions. I'm Charlotte Dobre. Don't forget to give this video a thumbs up, subscribe, and let us know in the comments below a question you have always wanted to know the answer to. There are two types of black holes in the universe. The first is supermassive black holes that are found at the center of most galaxies. These are not that threatening, unless our galaxy collided with, let's say, Andromeda, which it's low-key supposed to do at some point, but let's not talk about that. It won't happen for a few billion years, so I think we're good. There's another type of black hole that does pose a threat to our solar system, and those are interstellar black holes. They are created when a star goes supernova, and spoiler alert, they are invisible because they emit no light, unless they're consuming matter nearby, but I'll get to that in a minute. Point being, we would not know when a black hole enters our solar system. The closest black hole that we know of is about 6,000 light years away. It's called the Cygnus X1, and it's only 44 kilometers or 27 miles in diameter. It would cause absolute chaos before devouring our sun. Even though Cygnus X1 is relatively small, if it happened to pass through our solar system, or if it was even 1 light year away, it would begin to pull in comets and asteroids and hurl them around. The orbits of the outer planets would be altered, and the orbit of the sun would also be altered. Once it actually enters the solar system, that's when the fun stuff begins. As it passes through the Oort cloud, it would send space rocks hurtling at the planets, including Earth. The Oort cloud is a group of icy bodies that's about 186 billion miles away from the sun. Meanwhile, here on Earth, the only way we would know a black hole entered our solar system is the slight gravitational lensing it would cause, and the comets and asteroids that would be hitting our planet. When the black hole begins to tear apart gas giants and other material from the planets, it would create what's known as an accretion disk. An accretion disk is a visible region of superheated dust and gas that surrounds black holes. As the black hole got closer and closer to the sun, it would begin to draw in the sun's matter. Depending on how big the black hole is, it could take weeks or perhaps even hours. The matter that surrounds a black hole emits a ton of radiation and heat and would likely fry us. Perhaps the best way to describe what this would look like is the term space spaghetti. Get too close to a black hole and matter will begin to pull apart and stretch out like spaghetti. The black hole would swallow up the spaghetti little by little, not all at once, all the while emitting heat and radiation. And then a couple things could happen to the Earth. Any planet that got too close to the path of the black hole would be consumed. The intense gravitational pull of a black hole could also cause chaos on Earth. It could cause devastating earthquakes and supervolcanoes to erupt. Then eventually our planet also gets swallowed by the black hole. The second option is that the Earth gets knocked out of orbit and begins a journey into the black nothingness of space. Without the sun, the Earth would not be able to support life. And then there's a third option. The Earth could begin orbiting the black hole and life could live on for some time. In order for life to thrive, there needs to be a source of energy nearby. The black hole could technically become that source of energy in place of the sun. The only catch is the black hole needs to have stopped consuming material, otherwise it will be emitting radiation. Life on Earth could be sustained for a while, but the amount of heat and light that is emitted by the black hole would likely be a fraction of what the Earth receives from the sun. It's difficult to imagine the environment on Earth at that point.
Space. It's a pretty weird place, isn't it? Whether it's timey-wimey, upside-down stuff, strange exoplanets that rain torrential downpours of pure glass, entire cosmic oceans of neon gas, white dwarfs, red dwarfs, or perhaps the weirdest, most mysterious linchpin of all these space-time shenanigans combined, the black hole. The void itself, the dark maw of the universe, the biggest fan of theoretical spaghettification of all time, and I do mean all time because as we all know, time is a relative concept, right? Or is it a flat circle? I forget. But anyway, what if we took that mysterious cosmic void, threw caution to the wind and, I don't know, dropped a nuke in it? Just for the sake of it. Really? What would happen? Well, let's find out. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, what if we nuked a black hole? Roll the clip. For the curious amongst you, that clip was, of course, from 2009's Star Trek, directed by J.J. Abrams, because, you know, this is a video about black holes. And you deserve nothing better than the most cinematic visual depiction going. Or, well, the most appropriate, I guess. Anyway, it leads us to an important notion, because the fact of the matter is, despite their best efforts, fiction has tried its damnedest to try and visually theorize exactly what's going on down in the deep, dark bowels of a black hole. But the reality remains that no one exactly knows what would happen if we plummeted headlong into into the void. It could be a portal to another dimension, but it also could be a cosmic trash compactor that obliterates matter with its infinite density. But sometimes, as they often say, the truth is stranger than fiction. You see, the conceptual idea behind black holes has permeated its way across the scientific community for over 200 years, culminating recently with the first ever actual visual photograph of the coveted black hole. We took a photo of it, guys, and that's awesome. If you didn't know though, the first ever mention of something resembling a black hole was way back in 1783, theorized by a Cambridge don by the name of John Mitchell, who had written a paper in the Philosophical Transactions of the Royal Society of London about what he referred to as dark stars. Mitchell noted that any star that was sufficiently massive and compact would inevitably have such a strong gravitational field that even light itself could not escape. Well, of course, he was right, but it wasn't until 1915 when a particularly brilliant mind, our boy Albert Einstein, put forward his revolutionary general theory of relativity, and suddenly space and time were no longer thought of as independent entities, but instead just different metrics of a single object, space-time. And now it was all neatly mashed together. Space-time wasn't flat like the previous two parameters. It was warped and curved by the massive manner of matter and energy bounded across the cosmic expanse. And those curves and warps were dictated by the endless indents upon them and inside them, black holes. The result of what happens when a star gets too big for its boots and its density becomes even bigger than the Beatles. Well, of course he was right, and he sparked an interest in another particularly brilliant mind, Professor Stephen Hawking, who dedicated his cosmic joy of life to figuring out pretty much anything and everything of what the hell is going on with all these black holes. But guess what? Despite the indifference of Professor Hawking, we're going to theoretically send a nuke into one. But the first question is, which one? How many black holes are there? How are we even going to get into the position of shooting a nuclear rocket into it? Surely it's not as easy as firing off a missile from the surface of our planet and hoping for the best, right? Well, wrong. Of course, space is big, guys. Heck, our galaxy, the Milky Way, is really, really big, as in 180,000 light years in diameter. And bad news, because the nearest theorized black hole to our pale blue dot is 3,000 light years away. The fastest thing that we've ever created is the Helios 2 probe, which was launched way back in 1976 and traveled at a record speed of over 157,000 miles per hour, and incredibly enough is still in orbit around our sun today. Now, 157,000 miles per hour is incredibly quick, but when compared to traveling the distance of a single light year, yeah, it doesn't look too hot, does it? To travel one single light year at 157,000 miles an hour would take 4,269 years. And unfortunately for us, the nearest black hole, as we said, is 3,000 light years away. Guys, I hate to break it to you, but even if we sent a nuke right now that could travel at the speed of Helios 2, it would take 12,807,000 years to even conduct our experiment. And, well, as they say, ain't nobody got time for that. In fact, if black holes were cosmic portals to another dimension, it's entirely hypothetical that if we sent off our nuke and 12 million years passed for us to find out what happened, humanity and our planet could have come and gone, and we'd have disappeared entirely, lost in the sands of time, before we even found out the result. And perhaps we'd have never found out that our nuke that we haphazardly shot into another dimension actually landed smack bang into another planet, destroying it completely. It's the perfect crime, really, but we all know better than that, don't we? We don't just shoot off nukes without considering the potentially destructive consequences. So let's say that our civilization had finally figured out faster than light space travel, and a team of scientists headed over to our galaxy's nearest black hole with a nuke strapped to their vessel. They positioned themselves at a safe enough distance out of the gravitational pull of its event horizon. They hit the big red button, and the nuclear bomb plummets its way into the black hole. And what happens? Well, under our current understanding of physics, absolutely nothing. But not in the way that you may think. You see, within a black hole's event horizon, energy and matter become one, and those very same black holes can convert any varying degree of energy into mass. It gets bigger, guys. It's a black hole. And as we know, a black hole's mass is infinitely dense. Anything that happens in our universe, nuclear detonation included, denotes information, and thus information requires energy, and energy has mass. E equals mc squared. And well, a nuclear bomb has a hell of a lot of energy. In fact, a 1 megaton nuclear weapon releases energy equivalent to 4.18 times 10 to the power of 15 joules. While that's absolutely massive, that's only small fry comparative to the largest nuclear weapon ever detonated, the Tsar bomber created by the USSR with a yield of over 50 megatons. Whatever the degree of magnitude, if we fired our hypothetical nuke into a black hole, the likely outcome is that it would just add fuel to its fire. Our gigantic explosion would serve only to convert that entire dense and enormous mass into pure, unbridled energy, and again, as is the mechanics of a black hole, convert that energy back into mass. You see, it wouldn't matter how many nukes we sent into it, or how powerful they were, because in all reality, we could crash an entire star into a black hole, and it would still gobble the whole thing up, only getting bigger and bigger, chewing up the universe as it goes. Thankfully for us though, Professor Stephen Hawking theorized that black holes eventually dissipate their mass over a long enough passage of time. Given enough breathing space, even the most supermassive of black holes will eventually evaporate away into a harmless soup of particles. Well, theoretically, anyway. So for the time being, it's probably best to not fire any nukes into a black hole, or anything really, except an asteroid hurtling towards our planet. Yeah, we can nuke that. Safety first. I'm sure that you're all aware over here at Life's Biggest Questions, we've got quite the hankering for those complete and utter mind-bending enigmas of physics that keep us up at night wondering how long we've got left before they gobble up the entire universe and everything else with it. And no, I'm not talking about Cthulhu, I'm talking about black holes, although it's not entirely outside the realms of possibility that an eldritch great old one is lurking just behind the veil of the event horizon. But that's a different thought entirely, and one that I'd rather leave tucked comfortably in the far recesses of my mind. No, today we're going to be peeling back the lid of the cosmos in a different kind of dimensional manner. Hello internet, what's going on, and once again welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice Jack Finch, as today we curiously ask the question, what's behind a black hole? While it's important to note that while we've covered quite a few black hole escapades already, we're going to initially be paying our dues to some of the greatest minds that physics has gifted us so far, and answer this question with a very brief proposition. What's behind a black hole? Well, based on our current understanding of physics, nothing at all. No time, no space, just the singularity, the end of all things. But as is the case with many things, there may be something more to it, and theoretically speaking, what lies beneath these cosmic enigmas are the root of some of the greatest mysteries in our universe. Now obviously you may be thinking behind a black hole as in physically behind? That's ridiculous. How could you go behind a literal puncture hole in the fabric of time and space? And well, the quick answer is you're doing it right now, because as we speak, at the center of our galaxy there's a supermassive black hole known as Sagittarius A star, and pretty much everything in the entire Milky Way galaxy from our point of view is behind that black hole in a fashion. So there's your answer. What's behind a black hole? Me and you and everyone, thanks to the beauty of perspective. Alright guys, show's over. I'll show myself out. Okay, I'll digress, because of course that's a cop-out. However, because of that orbital effect in particular, we can actually bear witness to one of the most interesting and mind-bending events in the universe, where essentially if something is sufficiently luminous enough, such as a galaxy or a cluster of galaxies, that then passes behind a black hole from our observational position, a phenomenon then occurs that is known as gravitational lensing. And here's where things get really interesting. As the two objects pass between each other, we as observers would see the light of the luminous celestial object bend around the black hole as it passed, almost like a wave crashing against a tidal break. And what we then see is the immense mass of the black hole actually curving the space-time around it, so that the light from the distant luminous celestial objects, well, the light that doesn't go straight into the black hole that is, curves around it as well before passing on freely. In fact, gravitational lensing is often used as a sort of magnifying glass in astronomy, amplifying the light visibility of objects that are otherwise too far to be observed through conventional technological means. Essentially, in respect to black holes in particular, this effect only occurs because there is nothing behind a black hole, but that doesn't necessarily mean what you think it may. In fact, it may be incredibly difficult for us to wrap our brains around the fact that there is essentially not a thing as we know it behind a black hole, to the observable universe anyway. After all, if an object of matter exists in the physical space of the universe, no matter its physical dimensions, there has to be something behind it, right? We know what's behind the moon, we know what's behind an asteroid, we know what's behind the Tesla Roadster currently spinning its way across our solar system. They're three-dimensional objects, we know exactly where we stand with them, as well as all of the things that comprise the space between our Earth and their relative position in the cosmos. So what about black holes then? If they're not three-dimensional objects as we know them, then what are they? One-dimensional objects? Perhaps, maybe something like an electron? That would make the most sense, wouldn't it, given the fact that an electron is a one-dimensional point embedded into three-dimensional space, well, as far as we can tell, anyway. The thing is, it is often said by physicists that physics makes sense until you go into a black hole, and that's where the real paradox of this notion becomes apparent. Every single image of a black hole that you've ever seen has been depicted in the exact same way, and if that's not already confusing enough, then let me put it this way. Any image of a black hole is a two-dimensional projection of a three-dimensional event that's made to represent a zero-dimensional mathematical absolution known as a singularity. Yeah, exactly. And if things weren't already confusing enough, black holes, well, technically speaking, the event horizon of a black hole are three-dimensional celestial objects, but at the same time, they also fit the parameters of potentially being four-dimensional objects too. In fact, thanks to the scientific solution known as the Schwarzschild radius, which dictates that the properties of space-time inside of a black hole are entirely different than the rest of space, we stumble deeper into the ever mind-boggling long grass that is string theory, which suggests that black holes could very likely exist on up to an 11-dimensional framework. And I'm not even going to try and take a guess at what lies behind that. But here's another curveball that's just mustered up enough escape velocity and made it out of the event horizon of this particular life's biggest question, because very recently, as you all may know, our human species hit a home run, and we actually captured a whole damn image of a black hole for the first time in forever. Well, kind of. It was more like trying to take a photo from Earth of a DVD on the moon, but hey, it worked, and it's probably one of the most important discoveries in physics in a long, long time. Perhaps, though, coded within its pixels will lie the answer to the mind-bending spatial properties of black holes, and who knows, maybe we'll know exactly what dimensional plane we're looking at these things from. In all likelihood, it will probably just pose many more questions than answers. But hey, that's the fun part, isn't it? Well, there we have it, our short and long answer to the question, what's behind a black hole? Me and you, the rest of the planet, and who the hell knows? Probably like at least 7 more dimensions of even more questions. Yeah, that sounds about right. If you've got any thoughts on the matter or even an interesting insight into the mechanics of black holes, then please let us know your thoughts down in the comment section below.
Black holes are a region of space that have such an intense gravitational field that no light or matter can escape them. We know that supermassive black holes are at the center of almost every galaxy. These supermassive black holes are humongous. They are millions or even billions of times the size of our sun. But what would happen if a black hole hit another black hole? That's the question we are asking today on Life's Biggest Questions. Hello and welcome back to Life's Biggest Questions, the channel that asks the fundamental questions of life. I'm Charlotte Dobre, and on this channel we answer a question every single day. Topics range from science and scary movies to politics and history. If that sounds like something you're into, subscribe and join the notification squad. What happens when two gigantic space vacuums smash into each other? It's a fair question considering the fact that there are actually quite a lot of black holes in the universe. There are an estimated 100 million black holes in the Milky Way galaxy alone. There are actually so many black holes in the universe that it would be impossible to even count them, which is why it's entirely possible that one black hole could hit another. And in fact, it happens a lot more often than you'd think. If a black hole collided with another black hole, the bigger one probably wouldn't eat the smaller one. Well, not exactly. They also wouldn't bounce off each other and carry on their black hole way. Once they become trapped by each other's gravity, a huge cosmic event is underway. There's actually a name for that cosmic event. It's called a binary black hole. A binary black hole is when two black holes are in close orbit around each other. For a very long time, it was difficult to prove that binary black holes even existed, and that was largely to do with the fact that the instruments to detect them were not advanced enough. We simply just couldn't see them with traditional telescopes. But during the 20th and 21st centuries, the scientific community became very interested in binary black holes because proving binary black holes existed meant proving gravitational waves existed. Gravitational waves were predicted by Einstein's theory of general relativity. Detecting gravitational waves meant proving that they exist, and therefore would help us get a better understanding of how gravity really works. When two black holes get so close that they can't escape each other's gravity, they would eventually collide and merge to become one bigger black hole. When this happens, it undoubtedly releases an immense amount of energy, so intense that ripples are sent through the fabric of space-time across the universe. The gravity exerted by a black hole is so immense on its own, but two black holes smashing into one another? Well, that's another story. These ripples are called gravitational waves, and when black holes collide, they shoot out across the universe at the speed of light. In recent years, instruments capable of detecting gravitational waves from outer space have been constructed, like the Laser Interferometer Gravitational Wave Observatory, aka LIGO, which was completed in 2002. Then, on the 14th of September 2016, a merger of two black holes was detected by LIGO. The readings showed up as spikes. Astrophysicists had finally recorded two black holes colliding for the very first time, proving that gravitational waves exist. And also for the very first time, astronauts have recently observed two black holes getting closer together and then colliding. It's extremely hard for us to observe one black hole hitting another because there's so much dust swirling around the galaxies, obscuring their view from Earth. When black holes collide, it's a very violent occurrence. Matter and dust is thrown around and a thick curtain of material forms around the collision, so that the nuclei of the black holes can't be seen with conventional telescopes. Until now, it was not possible to observe two black holes colliding. But using X-ray data from the Burst Alert telescope, as well as laser capability of the Keck Observatory, scientists created infrared imagery of two black holes colliding. According to a survey of 500 galaxies, many galaxies actually have two merging black holes at their centers. This is because when galaxies merge, so too do their black holes. This is because when galaxies merge, so too do their supermassive black holes. It's an extremely long process. It takes billions of years to happen, but it ends very quickly. The black hole at the center of our galaxy, the Milky Way, and the closest galaxy to us, Andromeda, will collide in a few billion years' time. Right now, we're moving toward Andromeda at a speed of 250,000 miles per hour. In a few billion years, there won't be two separate galaxies anymore. They will be one super galaxy. In fact, one of the reasons why supermassive black holes exist in the first place is likely because they were once smaller black holes that merged, and so too did their galaxies. Don't you just love space? We still don't know a whole lot about black holes or what happens when they collide, but hopefully this video has provided some insight into what happens when one black hole hits another. Astronomers estimate that there are as many as 100 million black holes in our galaxy alone, and that there is a supermassive black hole at the center of almost every galaxy. Black holes are still quite mysterious. We don't really know a lot about them. Works of science fiction allow us to imagine that black holes could serve as gateways to other worlds. As far as we know, going inside a black hole is not the smartest idea, unless you want to turn into human spaghetti. But according to Professor Stephen Hawking, black holes could be wormholes that could provide shortcuts for interstellar space travel, which otherwise would be pretty slow and tedious. A wormhole, aka an Einstein-Rosen bridge, is essentially a shortcut through space-time. So let's expand on this idea in today's episode of Life's Biggest Questions and ask, what if humans could travel through black holes? Welcome back to Life's Biggest Questions. I'm Charlotte Dobre. This is where I remind you to hit the like, subscribe, and notification bell and ask us a question in the comments below. On this channel, we post 1 to 2 topics a day, so it's quite possible that we may have already made a video on one of your suggestions. Make sure you search our videos to see if we have. And if you would like to connect with the creative team behind Life's Biggest Questions, check out the description for all the links to our social media accounts. The idea of black holes has actually been around for a couple of hundred years. John Mitchell of Cambridge University wrote about something he called dark stars back in 1783, now known as black holes. Most scientists believe in the idea of the singularity, where a huge amount of matter is shoved into a tiny space, making a black hole. The gravity of a black hole is so intense, it is impossible to escape, even for light. The edge of a black hole is called the event horizon. It's the point of no return. Imagine the edge of a black hole as being a waterfall. Once you go over the edge, you can't climb out, unless you happen to be capable of traveling faster than the speed of light. As you get closer to the black hole, the speed needed to escape goes up, and at a certain point, the escape velocity needed to leave Earth's surface is about 25,000 miles per hour. Just for some comparison, considering that time only goes forwards and never backwards, once you went through a black hole, hole, you would be annihilated. There is, however, a way around this. We know that gravity bends space, but black holes are not ordinary objects. If black holes were able to rotate like other objects in space, then they could theoretically turn into a ring if they rotated fast enough. A ring singularity could provide a gateway to other universes, other time periods. This is what's known as a wormhole. The term wormhole was coined by physicist John Wheeler in the 1960s when he was examining the work of Einstein and Rosen. An Einstein-Rosen bridge is a tunnel through the universe that's essentially like a shortcut between 2 points in space. No one really knows what happens to all the matter and light that enters a black hole. So where does it go? Is it lost, or does it come out the other side? In a speech from 2015, Stephen Hawking said, "Black holes are not the eternal prisons they were once thought. The way out wouldn't take people back to where they came from, but instead they would reappear, but somewhere else." Perhaps in our advanced future, once we have used up all the resources on planet Earth, whatever remains of humanity will have to use wormholes to find other areas of the universe to inhabit. And maybe a wormhole could give us access to an alternate universe with other habitable planets. These habitable planets could be barren or already taken over by another intelligent civilization. Maybe this would mean that we would be forced to live alongside an alien civilization, or an interstellar war would begin. Let's hope this advanced alien civilization is nice and could share their knowledge of the universe with us, and together we could colonize the cosmos. Unlimited destinations for space travel would be at our disposal. Water worlds, fire worlds, rocky worlds, whatever you can imagine. We could also possibly use wormholes as time machines. We could theoretically alter the future by changing the past. Maybe we could go back in time and find out who shot JFK. Maybe we could try and stop Hitler. But changing the past could have dire consequences. One could literally erase our entire existence if they weren't careful. The ripple effect of changing one small thing from the past is incomprehensible to us. That being said, Stephen Hawking said that if we could travel through black holes, we wouldn't be able to come back to our universe. Once you entered a black hole, that's it. You're on the other side. And according to new research by postdoctoral fellow Peter Hintz, whoever traveled through a black hole would leave their past behind, and before them there would be an infinite number of possible futures. Yes, entering a black hole could take you to an alternate universe, but it would also delete your past, skew reality as we know it. Now as we come back to our reality, I will say that no one has really figured out the math of a wormhole to make it so that the gateway remains stable. Furthermore, no one really knows how a wormhole could come into existence. At this time, it's most commonly believed that if you entered a black hole, your mass is simply added to the black hole. You don't go anywhere. You would become stretched out into individual atoms by epically strong tidal forces. As you fall closer to the event horizon, eventually all you will see is blackness before you are dragged at the speed of light and stretched out into strings of atoms. This is what's known as spaghettification. Definitely one of the worst ways to die, and we don't recommend it. That being said, no one knows what happens beyond the event horizon of a black hole. Scientists currently don't know what happens when you exit the universe. We are nowhere near close to any black holes, let alone able to see what happens when we enter one. All we can do is use Einstein's theory of relativity to work out what might happen. Tell us, what do you think would happen if humans could travel through black holes?
Black holes fill me with dread, but probably only because there is so much mystery surrounding them. Should we be scared of them? Hello and welcome back to Life's Biggest Questions. I'm Rebecca Felgate, and today I'm asking, what is on the other side of a black hole? You guys seem to enjoy our what would happen if Earth was sucked into a black hole video so much that we thought we would delve deeper and decipher part of this mystery for you. Despite the mystery surrounding black holes, it is estimated that there are as many as 10 million or maybe even more in our galaxy, the Milky Way, alone. There are two types of black hole that we know of: supermassive black holes, which are at the heart of every galaxy, and stellar mass black holes. Supermassive black holes have the mass of millions of stars, and stellar mass black holes are still dense but on a much smaller scale, and they can move. We don't really know how supermassive black holes formed, but we do have some insight into stellar masses. This stellar mass black hole comes from the gravitational collapse of huge stars. Our sun, for example, would not be big enough to form a black hole. When stars, roughly 25 times the size of our sun, reach their end of life phase, they become supernovas, exploding outwards, but also imploding inwards, buckling under their own mass. Hole is perhaps not the right word for a black hole because they aren't exactly empty. They're actually very, very dense. So dense their gravity is so strong that they start drawing in other matter around them, and not even light can escape them. Time and space buckle around black holes, and the laws of physics as we know them start to break down. So what happens inside one, or what's at the bottom of one, or is there even another side? The true answer is we don't exactly know, but there are some key theories. As I said, black holes are dense. What's inside a black hole is the collapsed matter of the star, and in theory, this collapse goes on and on and on until things get thin thinner and thinner and denser, leading to a point of singularity. This is one theory anyway, and possibly the most credible. However, there are a number of theories as to what goes on beyond the event horizon, the moment something starts getting deconstructed by a black hole. The theory of loop quantum gravity suggests that there is no singularity, but black holes are simply folds in the universe. Everything we know about quantum physics tells us that information is never lost, that energy can't be created or destroyed, so perhaps black holes are folds or portals to older universes. We're gonna get very deep for a second, so hold on to your hats. Our main theory about the formation of the universe is that it came from one hot, dense point of singularity that expanded outwards, the Big Bang, if you will. The formation of the universe seems like the opposite of a black hole, which sucks in and deconstructs matter into a smaller and smaller amount of space-time. Perhaps the point of singularity in a black hole, the end point, if you will, is the starting point of another universe. This is pretty much what is discussed in the Big Bounce theory. So these are stellar mass black holes, the easiest type of black hole to study, as we cannot get anywhere near a supermassive black hole. There may be another type of black hole too. According to a NASA Q&A page, mathematicians and physicists have theorized that there are hollow black holes that don't require the collapse of a star to form. This type of black hole is imagined to have an exotic geometry and be a place where time travel is possible. Well, blimey, NASA, careful where you're spilling that huge can of worms. But of course, before we all get too excited, we should remember that time travel will only be possible if we're ever able to manage to move faster than the speed of light, which of course right now we're very much unable to do, but maybe one day. There is one more interesting thing to say about black holes, and that is they tend to leave ghosts behind them. By that I mean, as Stephen Hawking observed, the information contained in matter that falls into a black hole seems to be copied and frozen around the event horizon. As NASA puts it, this raises some interesting possibilities that we could resurrect clocks, humans, spacecraft, and whole planets into something like their pristine form if we could magically reverse the infall and collapse process. Whew, well, I think that is enough for one day. Fundamentally, the short answer is we don't know what exactly is on the other side of a black hole, but we have some good theories. We suspect it's infinitely dense, and some suspect it could be a portal to a new dimension. Spiders, ghosts, ghouls, guns, bombs, scary, sure, but nothing is scarier than a black hole if you really think about it. But luckily, we don't have to think about it or dwell on it too much. Yes, black holes are out there, sure, but they're pretty darn far from here. They're like a back-of-the-mind, planet-destroying menace. But what if one got all up in Earth's grill? Hello and welcome back to Life's Biggest Questions, the channel that loves to answer all kinds of queries from the serious to the whimsical, and I think this one falls nicely within our remit. I'm your host Rebecca Felgate, and today I'm asking what would happen if a black hole entered our solar system. Before we really get stuck into this video, I want you guys to tell me what you think is on the other side of a black hole. I think it could be a fold in space-time and the portal to another universe, but that is as of yet unproven. Let me know your thoughts in the comments section down below, and also if you want to connect with the team that went into making this video, then there are links to our social medias in the description box. Okay, black holes. Before we talk about what would happen to us, let's discuss the difference in varying types of black holes, because no, there isn't just one, and yes, the differentiation is important here. There are two types of black hole: supermassive black holes, which are at the heart of every galaxy, and stellar mass black holes. Supermassive black holes have the mass of millions of stars, and stellar mass black holes are still dense, but on a much smaller scale, and they can move. If, say, the supermassive black hole at the center of the Milky Way entered our solar system, it would basically be immediate curtains for us. The hole in question is called Sagittarius A, and it is 4.5 million solar masses in size. If something of that mass entered our solar system, we would quickly be drawn into it, it having unimaginably more gravity than the sun we currently orbit. It would be a hop, a skip, and a planet smash towards the event horizon, and depending on if our sun went first, it could be pretty cold and dark too. Thing is though, as unlikely as it is that any form of black hole will ever enter our solar system, it's especially unlikely and nigh on impossible that a supermassive black hole will ever swing by. We could move towards it, but that would take, well, to our human understanding, an eternity. So really, what we are left with here is the option of a smaller, more travelable stellar mass black hole. These are formed by the implosion of stars much larger than our sun, and can be up to 20 times the mass of our sun. It is estimated that there are as many as 10 million, or maybe even more stellar mass black holes in our galaxy alone. The nearest is Monocerotis, known as V616 Mon. It's 3,000 light years away and is thought to be between 9 to 13 times the mass of our sun. So, what would happen if a stellar mass black hole entered our solar system? There are some variables here, and the answer totally depends on the mass of the black hole and the distance between it and Earth. If a small black hole a few times the mass of our sun dropped by Pluto, for example, it may not have any real effect on us. But if a black hole the size of Monocerotis entered the very edges of our system, we may find ourselves more susceptible to asteroid hits, and we may also experience a slight slowdown of each Earth year as the gravity from the black hole affects our orbit speed. There is a chance we would see warmer summers and colder winters too. Now, if the black hole got closer, like say the distance of our gas giants away, well, it would have a real effect on them for sure. The gases would likely be sucked in, so say goodbye to the rings of Saturn for a start. We don't know how the core of other planets work truly, but if they're anything like ours, maybe the intense gravity of the black hole would crack them, breaking up the planets and drawing in their matter. Or maybe the outer planets of our solar system would begin to orbit the black hole instead of the sun. But would this mess with our orbit path, and would we see a planetary smash? Probably. At this distance, the black hole would affect Earth quite significantly. This could severely disturb our orbit, drawing us closer or further away from the sun, massively affecting our seasons, and perhaps knocking us out of our habitable zone. We're in what a lot of people call the Goldilocks line, the perfect coordinates for life. It evolved that way. Even a shift of a few thousand kilometers either way could destroy that, ending life as we know it. If the stellar mass black hole came even closer than that, very close to Earth, we would for sure be sucked into its mass slowly but surely, but not before huge tidal waves rip over the world, drowning us all. As we know, the Earth's tides bulge in response to the moon's gravity, and the moon's mass is a speck in the ocean when it comes to the mass of a black hole, so yeah, we all die. The effect of gravity from the hole's mass may even start to crack our planet's crust, causing supervolcanoes in which, you guessed it, we all die. Although good luck trying to kill me twice, black hole, you son of a gun. And yes, eventually the whole ball of joy, our beautiful planet Earth, would be torn up and gobbled up atom by atom in a stretch of delicious particle spaghetti. But is that the end? Circling back to the whole kill me twice thing, there are still a lot of questions as to what is on the other side of a black hole. Some scientists, including the late great Stephen Hawking for example, thought the black holes could be folds in the universe, or the portal to another altogether, and all of the matter spewing from it creates something new. It's a bit of a mind bender, but honestly, we really don't need to worry about it. Our solar system has been surviving and thriving for around 4.5 billion years, and there is no evidence that we have ever encountered a black hole, and there really isn't one near enough by that is traveling towards us to worry that we ever will. It is fun to imagine though, right? Although, I will leave you with one final fact to mull over. There is something scientists have created on Earth called the Large Hadron Collider. This particle smashing machine could possibly have the ability to create a mini black hole. What would happen then? Well, that's a different question to be answered another day.
Now, growing up, moving house is a pretty traumatic experience, right? You're born, you get settled down, you've got your group of friends, you're comfortable at school, and then all of a sudden, poof, new school, new neighborhood, everyone's weird, and you don't like them. But what if millions of years in the future, we weren't just moving house, but moving planets, entire solar systems? And not only that, but your brand new house on a brand new planet is in a pretty rough neighborhood, to say the least. And as it turns out, your new neighbor is a gigantic black hole. What the hell? Oh, and also, you are humanity, and this is a metaphor. Ooh. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, what if you grew up on the edge of a black hole? Well, the first thing that we have to explore when facing this question is why the hell would anyone ever want to live on a planet right on the edge of a black hole? Surely, regardless of the infinity of both the universe and the stupidity of mankind, we'd never be so foolish as to inhabit a planet teetering on the edge of an event horizon, right? Those things are dangerous, they love spaghetti, and they have a habit of swallowing things whole. Now obviously we have to do a little bit of hypothetical gymnastics to even get to this point, and the major proposition is a bit of a leap to say the least. You could even say a giant leap for mankind. Eventually, as in approximately 100 trillion years, we know through our understanding of the life cycle of our own sun that all the stars in the known universe will die out, and the only cosmological bodies that would remain would be these guys, black holes. Albeit really big black holes. Eventually, it wouldn't be outside the realm of possibility that all surviving life in the universe will have to emigrate to planets that surround black holes down to their civilization's need to harness energy. And with all the stars burned out, black holes would be the only source of usable energy, thanks to a little function known as the second law of thermodynamics. Also, it's important to note that it's much more likely that any future civilizations will probably absorb energy by coalescing their own matter rather than moving their entire population next to a black hole. That's also if anyone's obviously still alive by then, but that doesn't fit into our hypothetical question, so let's throw that notion out of the window and out into our fictional black hole. Goodbye. Obviously, our theoretical planet needs to be able to sustain life, and thankfully, thanks to theoretical physics, it can. According to the second law of thermodynamics, the ingredients for life require a difference in temperature to provide a source of usable energy. Life on our planet exploits that difference which occurs between our sun and the cold vacuum of space. But conveniently, it still works exactly the same if you reverse it. Well, kind of, as in it also works with a cold sun and a hot sky. Thanks to Hawking radiation, which is a process that occurs toward the end of a black hole's life cycle, a big enough and old enough black hole could theoretically function as a sort of cold sun, or a black hole sun, to quote the immortal words of the late great Chris Cornell. So what would an advanced civilization even do in their strange new home? What are the health hazards? What are the schools like? Is there a dog park? Does this bizarre black hole friendly planet rain molten aluminium? Well, yeah, probably. In fact, due to time dilation, the likelihood of our new planet being incredibly superheated is highly likely, and the parameters of your new interstellar neighborhood not being covered in a tidal wave of liquid metal magma teeters on the edge of theoretical physics. But again, for the sake of this hypothetical resolution, let's throw that out the window yet again. Goodbye. Because the fact of the matter is, theoretical black hole neighborhood physics lets us envisage some incredible new features for our black hole civilization that is just too fun of a notion to pass by. If you were a citizen growing up in this brave new hypothetical world, you could imagine an entire method of technology and infrastructure based around the bizarre scientific properties of black holes. The nearby black hole itself could be theoretically used as a source of clean energy by harnessing the maximum rotation of its innermost stable circular orbit and harvesting the subsequent radiation. Hell, our civilization could even go one further by engineering a device that would work in harmony with the spin of the black hole, acting as a giant flywheel to harness momentum as energy. That's pretty ballsy, right? But we can safely assume that any civilization willing to live next to a black hole knows a thing or two about physics at this point. In fact, this black hole could even form the basis of an entire social structure, even going so far as forming our civilization's judiciary system. You grew up committing a life of crime? Sorry, bud. Guilty. You've just earned yourself a one-way ticket to the ultimate prison, the black hole, a death sentence of a singularity. Now that's a pretty terrifying notion, isn't it? also, if we haven't yet hammered home our point enough already, growing up around a black hole would even have consequences for how our theoretical civilization perceived time relative to our own. Thanks to the craziness that is time dilation, it's entirely possible that you could have moved to your new black hole planet and several million years have passed by in your old neighborhood. Now that is an existential crisis if I've ever had one. I need to lie down. Obviously, everything posited here is a giant leap for our hypothetical civilization, but isn't that the pure unbridled joy of imagining strange new worlds, even ones that require theoretically carving out an entire existence on a planet teetering on the edge of a black hole? In that case then, I'm glad that we've all grown up, so far at least, on our Earth. After all, when you think about it, we're pretty damn lucky that we don't have to move to a black hole anytime soon, right? Well, there we have it, our hypothetical notion to the question, what if you grew up on the edge of a black hole? What do you guys think? Would you ship off in the first spaceship bound for the nearest black hole? Let us know your thoughts down in the comment section below.